Hello, everyone. I guess you're back for more fun. We're all back for more fun. We're all having a good time. Are we really? Yeah, of course we are. Just kidding. I am. But hopefully it's not too much torture for you guys. So this section, we've been solving a lot of equations, right? And we've been solving them, but we don't really know why. So this section is kind of a why do we care about equations? Where are they used in real life? And yeah, things like that. And this is just one example. We'll see more applications in the future. But this is kind of a good section. You'll see this a lot, actually. In this book, this is us just kind of starting out dealing with formulas. Later on in this book and in this course, we'll be solving more formulas, having more fun with them, more complicated ones. And then as you move on to the next math class after this, you'll see them again. So they keep coming back and they keep getting more complicated. So this is just the beginning, and I think if you get a good foundation right now, right off the bat, then you'll be fine once you move on to the more complicated ones. So formulas. I'm sure you've seen formulas before. I don't even know why I put a definition in here, but just in case, maybe you've heard of them and you say, well, what exactly is a formula? I mean, what is and what's not? So a formula, it's an equation that shows a relationship between variable quantities. So pretty much a formula, it's just an equation with more than one variable in it. But for the most part, we only care about formulas that actually represent something in real life. So for example, here in example 1, we see the circumference of a circle, it's 2 times pi times r, where r is the radius of the circle. So that means if you take a circle, I'm going to pretend like I'm really good at drawing here. Pretend like that's a circle. It's not very nice. And let's say and the radius, as you know, is from the distance from the very center to the outside. This is the radius. If you take that radius, you multiply it by pi, that number 3.1415, on and on and on, it goes on forever. And then you multiply that by 2, you get the distance around, that's the circumference. So if you go all the way around the circle, starting here maybe, walking all the way around. So it's interesting. I always thought circles are interesting like that because it doesn't matter what size the circle is. This is a little one. If you get a big one, still it's true. The distance around the circle is 2 times pi times whatever the radius is. It's pretty interesting. So anyway, that's if you're a math nerd, I guess. But another example, probably more useful to the average person in real life. Not everybody really cares about circles and their circumference and all that stuff. But let's say, you work somewhere and you're paid an hourly wage. Let's just say $11.50 an hour. Okay, so if you get paid $11.50 an hour, and then at the end of the month, how do you figure out how much you're going to get paid total? Well, you take the number of hours you worked, let's say that's H for hours, and you multiply it by 11.5, right, or 11.50. So you probably already knew that. This is just a formula, I guess. It's like, S stands for my salary, how much I'm going to make, and then H is how many hours. I can figure out my salary by taking H, the number of hours, and multiplying it by $11.50. Bada bing, bada boom. So you've probably been using formulas and not even knowing it, You don't write it out, you just kind of do it all in your head or on your calculator or something. So first thing in this section is we're going to learn how to use formulas kind of to get what we want in real life situations. And there's a couple interesting examples here, I think. And then after that, we're going to get to probably more the stuff that you're going to see, like I was talking about earlier, over and over in this course and the next course. We're going to see in example 3, I don't want to jump ahead too far, but you're going to take a formula, which they don't really tell you what it means. You got E equals mc squared. I'm sure you've heard of Albert Einstein. He says energy equals mass times the speed of light squared. Who comes up with that? That guy was on another level, Anyway, they just give you a formula, and they don't really want you to, find out what E is or find out what... All they want you to do is they say solve for a certain variable. And by that, they just mean get that variable by itself. But okay, we'll talk about that more. Over here in this box, it kind of outlines how to do that and what they mean by that. But, sorry, I'm getting all excited. Formulas are so much fun. I can't contain my excitement. Let's start. First things first time. Example 1. This is just kind of to get us in the mood for formulas. So we got a formula right off the bat in this section, or in this example. The formula m equals 1/5 t. I'm sure that's going to be important. Maybe I'll write that down here. What does that represent? It says it can be used to determine how far, m in miles. Okay, so that means m stands for distance. How far you are from lightning when its thunder takes t seconds to reach your ears. I know they always have, there is something where they say, if you see lightning, count, I don't know, you count a number of seconds until you hear the thunder, and that's how many miles away it is or something. I think that's kind of accurate, but this formula is probably more accurate. So yeah, if you see lightning and then you hear thunder, count how many seconds it took between the lightning and the thunder, and put that in here for t, and that'll tell you how many miles away that storm is. So let's see, how about, in this specific example, they're saying, let's say it takes 10 seconds for thunder to reach your ears on a specific day. There's a storm outside, you saw lightning, and you counted 10 seconds until you heard the thunder. They want to know, all right, how many miles away is the storm? Well, I guess what they gave us was t. T is time, so we know t is 10 seconds. So I think that's the main thing about formulas, is trying to remember, if they give me a number, what letter does that stand for? Or what variable is that? 10 seconds, was that m or was that t? It's good to remember that this guy, m was distance, in miles, and then t is time. So that way, if they give you a number like 10, let's say, all right, was that distance or time? Well, it was 10 seconds. That's time. So, okay, that's where it's going to go. And then really all you have to do is substitute it in for that variable, and then try to simplify, and that'll be the 1. So it looks like we have 1/5 times 10. And this is another one of those times where you have a fraction multiplied by a whole number. So I'm going to put that whole number over 1 and multiply across. Although, as you probably know by now, I like to reduce early. So I see that the 5 and the 10 can be simplified. 5 can go into 5 once. 5 can go into 10 twice. So that's really just 2 over 1, which simplifies to 2. Wow, that means that the storm was 2 miles away. That's not that far, huh? That's a little scary. Interesting. So if you count 10 seconds, I'm sure you've probably counted less than that before, huh? That's a little scarier. That means it's closer. All right. That's an interesting example. So hopefully you think it's interesting. If not, maybe the next one's more interesting. Let's see, example 2 here. Let's say, okay. Oh yeah, if you like sports, maybe this will be sort of interesting, but even then, maybe not. I hope so. It says, okay, when all n teams of a league play every other team twice. So I guess maybe there are some sports where you do that. You don't just play each other once, you play each other twice. I don't know. Believe it or not, most math people aren't really good at sports, so I guess we're saying n is the number of teams. I got to keep that in mind. N is the number of teams. All right, and then what else is there? G is another variable. That's the number of games played. All right, I like to kind of keep track of what's what, and that way if they give me a number, I'll know where to put it. Is that N or is that G? Did they give me the number of teams or did they give me the number of games? That's pretty important to know, or else you might find the wrong answer. So they're saying, okay, here's our formula. G is n squared, or n to the second power, minus n. And they're giving us a 7 here, 7 teams. All right, now I got to remember, was that n or G? Let's see, teams. We said that was n, right? N is the number of teams. Okay, that's right. So all I have to do is substitute 7 in for n. And that should give me G, which I assume that's what they're asking for, right? 7 teams, how many games are played? Yep, that's what they want to know. And this formula just happens to have two of the same variable, n. That just means you're going to replace both n's with the same, 7. And let's see, of course, you got to do order of operations here. I can't subtract the 2 first and then square. Because in order of operations, exponent comes before subtraction. So I have to square 7. Remember that means 7 times 7, not 7 times 2. That's 49. And then I'll subtract 7, and that should be it. All right, looks like 42, huh? So 42 games were played. That seems like a lot of games, but hey, if there's 7 teams and they're each playing every other team, twice, I guess that's a lot of games, huh? Interesting. All right, if you don't think that's interesting, I don't know what to say. I'm sorry. It's probably kind of as good as it gets in this section. So all right, those problems had a lot of context. They said this formula stands for this, and here's a specific example. In this specific example, what's going to happen? But in these coming examples, they're they're really general, and you're not really, I don't know, I think your answer is not going to be very satisfying. Because, like, for example, we were talking about this guy. The example 3 says, solve E equals mc squared for m. All that really means is isolate m. So I kind of tried to outline it over here in these steps over here. It says, okay, if you have a formula and you want to solve it for a certain variable, what that really means is isolate that variable. So in the end, since they said, oh, solve for m, what you're going to want to see is m on all by itself on one side or the other. And so you're going to be using the same steps that you used in the last section where, let's say there's something I want to get rid of. If it's adding, I want to subtract it to get rid of it. If it's multiplying, I want to divide it to get rid of it. So it's the same kind of idea, but it seems wrong because these aren't really numbers. Most of these are letters. But like it says, the key here is you want to treat all other variables as if they're constants. So in this example 3, they said solve for m. So I'm just going to pretend e and c squared are numbers. Let's say. And maybe, I think once you get the hang of this, you're probably going to be fine. But maybe just for the first example, to make it easier, I'm going to actually pretend like those are numbers. So I'm treating e and the c squared like numbers. So let's imagine. And you can just make them up, just so you kind of know what to do. Let's say e is, I don't know, 10? That's just what came to my head. I don't know. But then m is the variable you're trying to solve for. So I don't want to make that a number. But the c squared, you're pretending like that's just some number. Let's say, I don't know, 2 squared? Something. Yeah, whatever you want. It doesn't, this is just there to try to help you get an idea of what to do. But now that these are numbers, I see it seems kind of easier or more natural to solve for m. And I mean, at this point, of course, if this were a 2 squared, you could just say, oh, 2 to the second power, that's 2 times 2, that's 4. But since I can't do that, since I have a c here, I don't know what c is. I'm just going to pretend like I'm really lazy. Like, oh, I can't be bothered to figure out what 2 squared is. Well, just pretend like you have to leave it like that. If I wanted to isolate m, what would I do? Well, I guess the thing that's keeping m from being by itself here is the 2 squared, right? So what's 2 squared doing with m? What's the operation? They're multiplying since they're right next to each other. So I'll do the opposite and divide by it. 2 squared, all right, he's all by himself. And again, I'm trying to pretend like I'm really lazy, like, 10 over 2 squared, I don't really care what that is, as long as I have m by itself, So if you ever get stuck, you can always do that. Just say, all right, all these variables are freaking me out. Let me replace every variable but the variable they want me to solve for with a number, just to give myself an idea. And now that I have that as a model, now I'll know what to do over here on the actual problem that I was given. So what I did when I changed them to numbers is I decided to divide by 2 squared. So I think that's what I'll have to do over here, except I have a c squared. And divide both sides by c squared. And that way I'll have on the right side, well, I guess the c squareds will cancel, right? C squared divided by c squared. Anything divided by itself is a 1. So it ends up being like m times 1 on the right side, which is just m. On the left side, you have e over c squared, which there's not really anything I can do with that. I don't know what e is. I don't know what c squared is. If there were numbers, I can actually simplify that, but that's really all you can do. I know it seems silly, but that's all they want. They just make this equation look different so that one guy's all by himself. That's it. It's kind of strange, right? Doesn't seem very satisfying. I want to know what m is. Is m 7 or is m 23? But that's all they want. When they say solve, they just mean isolate. So these problems are very strange. They're kind of hard to get used to, but they're important, and you'll see them again and again. And the more of them you kind of tackle, the better you'll get at them. That's the good news. So let's try example 4 here. This guy looks kind of interesting. It's more complicated, huh? But it's similar. So maybe, again, this is optional. It's only if you kind of feel like you don't really get these or they kind of make you nervous. What I'm going to do is, other than the variable that they want me to solve for, q, I'm going to change every other variable, the p and the r, into numbers. And you can make up whatever. There's no wrong answer. Maybe just keep them simple, right? Let's say p is 3. I don't know. Whatever. And then r is 5. Sure. But q, again, that's the variable they want me to solve for, so I do not want to change him. I'm going to leave him as is. And there's already a 2 on the bottom. It's already a number. There's no need to change that. So this is kind of your scratch work, I guess, just to give you an idea of what to do. But again, you do not have to do this. If you already kind of know how to solve these, you feel like this is kind of silly to do this off to the side, then that's fine. But so, okay, if I have this, what do I need to do to get Q by itself? Well, that's tricky, huh? I think, so what's preventing Q from being by itself? It's both the 5 and the 2. But, okay, what should I get rid of first? I think if, let's say I try to get rid of the 5 first. What if I multiply both sides? Or not multiply, sorry. What if I subtract 5 from both sides? Like here, okay, subtract 5, subtract 5. Well, the 5 that I just wrote on the right side, that's not going to interact the way I want it to with this fraction. Because, again, this 5, it's not over 2. The only way that this 5 and this 5 can interact is if they have the same denominator. So, because this is a fraction and this is not. So it's probably not the right way to go. I probably don't want to get rid of that first. I think a good rule of thumb is, if you want to isolate a variable, move things over the further they are from the variable. So if I think about it, okay, right now, what's the closest thing to Q? Well, the negative sign, so that's probably the last thing I'm going to get rid of. But then after that, the closest thing is probably this 5. I think right now the furthest thing away that's still on the same side of the equal sign is this 2. So that's kind of a good rule of thumb if you're not sure what order to get rid of things in. And this goes for solving equations like in the last section or in this section. So I think I need to get rid of the 2 first. So I think, okay, to get rid of the 2, what's the 2 doing? What's the operation there? Well, I think it's dividing. I mean, it looks like a fraction, but again, you can always think of a fraction as division. So I'm going to do the opposite and multiply 2 on both sides. That'll work, because here, if you're dividing by 2 and then you're multiplying by 2, those can't, they cancel each other out. Or you can think of it as put this 2 over 1, and then the 2's cancel along the diagonal. And all you're left with is 5 minus Q. You could say over 1, because you're supposed to multiply across, but if you don't write the 1, that's fine, because we know that anything over 1 is that thing itself, so I don't really need that 1. And on the left side, we just have 3 times 2, which is 6. So that's not too bad. I don't mind that so much. Alright, and I think at this point now I realize I don't need that 1. I'm just going to rewrite it without the 1. Because yeah, any fraction whose denominator is 1 can always be reduced to a whole, kind of a whole number that's not a fraction. Alright, now where am I? I want to isolate Q, so probably my next move would be to subtract 5. Since 5 is positive, I'm going to subtract it to get rid of it. That will leave me with a 1 on the left, and not quite a Q on the right, it's a negative Q. But we know by now how to get rid of a negative. We got to divide by negative 1. We've seen this a few times. Alright, so I think we have Q by itself, and I'm kind of losing track of why we're doing this. Why did we do this again? Oh yeah, that wasn't really our answer. That was just, this whole thing we just did was just to give us an idea of what to do to solve this thing. So, but the good thing is I can kind of just copy all the same steps. I'm going to rewrite this guy and see what did I do over on the left and try to copy it. So the first thing I did was multiply both sides by 2, which is a good move because I have a 2 also that I want to get rid of. So I'm going to go 2 times both sides. These 2's will cancel just like in the work I did on the left. And then on the left side of this equation I have p times 2. You could write p2, but as we know, we usually see the variable on the right and the number on the left. So I'm going to write 2p, even though I multiplied on the right side. We know that when you multiply 2 numbers, it doesn't matter what order they're in. And then, okay, on the right side, all that's left is the r minus q. And then I can consult, what did I do over here on this other side? I then subtracted the 5 here. But I don't really have a 5, I have this r. So I'm going to subtract r. Just thinking, 5 is analogous to r. And I don't know what p is and I don't know what r is, so I can't really subtract them. They're not like terms since they have 2 different variables. And then again, unfortunately, I'm not left with q, I'm left with negative q. So I'm going to have to divide both sides by negative 1, just like the very last step I did over there. Alright, so we pretty much have it. I just think that the left side here can probably be simplified. Because let's see, if I divide by negative 1, you know what I can do is I can say, you know what, dividing by negative 1, that changes everyone's sign. Or I can think of it as give each, let's see, alright, I think I jumped the gun, sorry. I'm going to erase that little negative there, I don't need that. Whenever you have a fraction whose denominator only has one term, like notice this is a fraction, maybe the numerator has two terms, that has 2p and r, but the denominator only has one term, -1. You can split the fraction up if you want and give each of those terms their own denominator. So kind of go, oh, the 2p over -1 and then the -r over -1. That just kind of allows you to simplify each one separately. And let's see, then that would mean 2p over -1, that just changes the sign to -2p. And then you have -r over -1, that combines to make positive r, because it's a negative divided by a positive. Alright, and we did it. That was kind of a painful process, was it not? Ooh, so this was the real work was over here on the right. This part over here is kind of all optional. You don't have to do that. It's just, if you get stuck, I would say that's probably a good way to go. But if you're not stuck, if you think, I'm kind of getting the hang of this, I don't think I need that, then you don't need to do that. It's just more of this work over here that we really want to see. So hopefully that was good. I know these problems are very confusing. I remember learning these for the first time, and I was very confused, and I wasn't really grasping it like I thought I should. But then, yeah, the more of them I saw my instructor do, they got a little more accessible, a little more understandable. And then when I tried my own, I was struggling, but I don't know, I just got better and better at them. So if these seem really strange, don't feel bad. Don't feel bad at all. You're normal. So let's see, this next one, I don't know. We have 4x minus 3y is -12. And we want to solve for y. The one thing I do like about this problem is that there's only two variables, as opposed to in the last one we had p, q, r, a bunch of variables. So that's kind of nice. And again, it's optional if you want to replace every other variable other than the one you're solving for with a number. So I might try that, maybe see what to do from there, or replace x with something, but not y, again, because the variable you're trying to solve for you don't want to replace. What do you want to replace it with? I don't know, how about 6? Sure, why not? Alright, and this is the thing is, because you don't really know what x is, I did put a 6 for x, but I don't really know what it is up here. I'm going to pretend like I'm too lazy to bother to multiply these. Just say, 4 times 6, that's something, I don't know. Let's just say, who knows what it is? I mean, in my mind, I know it's 24. Or if just don't rewrite it, because you want to keep it as similar to the original problem as possible, 4 times something. But you can kind of keep in mind it is 24. So okay, let's say, what if that was a 24? How would you solve this equation? Well, the first thing I would want to do is get rid of that 24, right? Because you want to get rid of what's being added or subtracted with y first, before you get rid of what's being multiplied or divided. Oops. See, I'm thinking of it as a 24, but I'm not supposed to write 24, because I want to keep it as similar to what I have as possible. So I'm going to subtract 24, but I got to keep in mind I want to keep it looking like 4 times 6. I know it seems silly, but again, I think if we wrote 24, it would kind of defeat the purpose of doing this, because we want to have a way to solve the original one. So that means we want to keep what we're doing right now as similar to the original as possible, so we can model our problem after this. Alright, now if those two make 0. 4 times 6, subtract 4 times 6 would make 0. So only -3y is left. On the right side, I would want to combine these, -12 and then -4 times 6. But again, I'm pretending like, oh man, I can't be bothered to combine those. I'm just going to leave it. Because that's how our answer is going to look for this actual problem. Let's see, and then if I want to solve for y, the very last thing to do would just be to divide by, let's see, would I divide by 3 or -3? Well, I could divide by 3, but if I did, I would still have a negative left. So I think what I want to do is be greedy and divide by the whole thing. There we go. That's a beautiful thing right there. All right. -3 divided by -3 is 1, so you could just say that's 1y or y. And then on the right side, I really am tempted to simplify this, but I gotta pretend like I can't. And this is a good answer, or we can rewrite it like we did on the last problem. We were saying, if you ever have a fraction where there's only one term in the denominator, like we have, it's just -3, you're free to write it as each term in the numerator over that denominator. So I got the -12 over -3, and then I'm going to write -4 times 6 over -3. I think that's usually a good idea because it kind of gets rid of, if you have a double negatives, you can simplify that. Here's some double negatives, you know, things like that are kind of nice. This, I mean, I can simplify this. 12 over 3 is 4, and it's a negative over a negative, so it's a positive. And then here, the next fraction, we also have 2 negatives, so that'll be a positive. I'm going to try to leave it as 4 times 6, though, because I'm trying to remember that in the actual problem I'm given, I have 4 times x. So I can't really let the 6 interact with anything else, because I don't really have a 6 in my example. I actually just have an x. So this is probably what our answer is going to look something like, this guy right here. That looks, yeah, it looks strange, but okay, that was a long process. I'm going to try to model what we have after that. Okay, let me rewrite what we have. We have 4x minus 3y is negative 12. And I got to remember, I'm trying to solve for y. So our first step on the left side was move the 4 times 6. But, you know, we don't have a 4 times 6. We have a 4 times x. So I'm going to move that entire thing over. 4 times x. It just seems kind of wrong, right? It seems like, can I really do that? I mean, is that a valid move? Yeah. And 12 and, let's see, negative 12 and negative 4x, they're not like terms, so there's not really much I can do there. I'm just going to leave them. Your answer is never going to look pretty on these. It's always going to be really complicated and ugly, and it's probably going to bother you like it bothers me, but, you know, that's whoever's problem it is to grade this, you know? All right, now what? Now, if I want to isolate y, what's the next thing we did? We divided by negative 3 on both sides. All right, I'm going to go ahead and do that. Y would be all that's left. And then I think the next move we made, remember we said, I can split this fraction up. Write the negative 12 over negative 3, and then the negative 4x over negative 3. Although over here we had a 6 instead of an x. And then maybe I can simplify one of those or both of those. That would be nice. Well, this becomes a 4, just like we saw over here. And this fraction, oops, sorry. This fraction, there's not a whole lot we can do with it. I mean, 4x over 3, I don't know what that is, but there is a negative over a negative, so I can write it as a positive 4/3 x. And I know that answer is not very satisfying, but unfortunately, that's our answer. Isn't that sad? So these problems are very strange. It takes some getting used to, and I think, I don't think you really need to know how to do these problems in the immediate future. I think what they do is they try to introduce them a little bit now, so that when you see them later, it'll be easier. I don't think they really think you need to know these now. It's just, yeah, again, if you take your next math class, this stuff will be easier because you've already seen it. All right, so bear with me. Hopefully it's making some sense, but like I said, if it doesn't make perfect sense, it's okay. Don't worry about it. But I think, you know what, this next one, I'm thinking, you know what, this one doesn't have a lot of variables. It's a lot of numbers, so I think I'm going to be brave and try to just solve it without doing what we did before, where we change the variables to numbers and all that. Yeah, that's kind of usually how I approach these guys. I say, you know what, if there's a lot of numbers, I think I'm okay, because I feel safe manipulating numbers, but I don't feel safe manipulating variables. So I just got to keep in mind, we're solving for s. All right. Let's see, I'm trying to isolate s, and you know what? For some reason, what comes to my mind, and I always tell my students, is if you're solving for s, what you want to do is pretend like you're sneaking up on him. So you guys ever seen, I don't know, like Mission Impossible or 007 or something? Imagine you're a spy, and you're trying to get this guy S. He's a bad guy. And you've got to sneak up on him. And he's got, I don't know, let's say P, that's his bodyguard or something, and 1/2, that's like his guard dog, he's sitting outside the room. Like these parentheses are the room he's in. There's a guard dog, you got to take him out. And then this 115 is really far away, so I'm going to pretend like that's, I don't know, a security camera way out in the front yard or something, or maybe another security guard that's out in the front yard. So, you know, if you try to take out P right now, his friend, his bodyguard, he's going to notice because it's sitting right next to him. But what he will not notice is if you take out the 115 because it's so far away from him. So that's probably the way to approach these. For some reason, that makes it make sense to me. And you want to move things over the further they are from your variable. That's a good way to remember it. Yeah, move things the further they are from your variable. It's a good thing to remember. All right. So, and again, I really want to combine the two things on the left, but I don't know what A is. So a minus 115, that's not really something I can figure out. I'll just leave it like that. Then we got a 1/2 left times p plus s. All right, now I ask myself, what's the next thing that s might not notice I take away, you know? Again, if I take away his bodyguard, he's sitting right next to him. He's going to notice that. But this 1/2, it's outside the room they're in, that guard dog or whatever it is. I think I could take out the guard dog without him noticing. But let's see, 1/2, it's being multiplied by p plus s. So I think, and we talked about before, what's the best way to get rid of a fraction that's being multiplied? It's to multiply by the reciprocal on both sides. So I could divide by 1/2 on both sides, but I don't think I want to do that. I'm going to multiply both sides, because we said that's kind of the faster way. All right. I just got to be careful because I'm multiplying the entire left side by that. So to indicate that, I'd better put that in parentheses. Because if I didn't put parentheses there, it would just look like the a is being multiplied by 2/1, when it's really the entire left side, a minus 115. All right. And then if I think about it, 2/1, that's just 2. So it just so happens that the reciprocal of 1/2 is a whole number. There's not really a need to write it as 2/1, except maybe here when you're looking at reducing, you know. The 2's cancel, so all you're left with is a 1, which means it's just 1 times p plus s, which, 1 times anything is that thing. So this really just becomes p plus s. So we're getting closer. And at this point, I don't really need the parentheses because the parentheses were only there to separate the 1/2 that was outside from the p plus s. But now that 1/2 is gone, there's nothing in the front of the parentheses. There's not really a need for them. Okay, we're almost there. Okay. Halfway through these problems, sometimes I kind of forget what I was doing. Say, wait, what was I trying to do again? Oh yeah, isolate s. That's right. I want to get this guy all by himself. There's not really sneaking up on him anymore. All that's left is his bodyguard. So I just got to take him out. Since it's adding, I'm going to subtract it to move it over. And then he'll be all by himself and he can't hide for long. And the left side is not going to look pretty. It's just what was already there, the 2 times a minus 115, and then I subtracted p. And there's not really much I can do with that. I mean, it's kind of debatable. To me, that answer looks fine. Although someone else might say, I think I want to distribute the 2. I think it'll look prettier. That's fine too, if you think that's what you want to do. I don't think either one's way better than the other, but say I'll multiply 2 times a, and then 2 times 115 is 230. And there was p at the end. There we go. So, I mean, either of those is fine. I wouldn't say one's better than the other. Just so if you have an instinct to distribute, that's fine. If you say, I don't really want to distribute, that's fine too. Really, the main thing is as long as the variable they want to be by itself is by itself, then you're doing a good job. All right, we're almost done. We're getting there, you guys. What do we have here? The next example. Okay, this is kind of a complicated one because you notice that the variable they want you to solve for, x, this is the first time we've seen our variable occurring twice. So I see x twice in this equation. And unfortunately, these aren't like terms. Rx, xs, they have different variables. I mean, they do share x, but they have different variables, r and s. So there's no way to combine them. What we have to do is, I kind of outlined it up here. I kind of didn't talk about it because we didn't need it yet. But it says, this is what you do if you see your variable twice. So if the variable you are solving for occurs more than once, like we have 2 x's, what you want to do, it's hard to remember this, but the only thing to really do is you want to factor it out like we saw before. I don't know if you remember when we reviewed the distributive property in, what was it? The review video. We said, usually you distribute something, but there are times where you want to factor it out. So you got to pretend like someone distributed, already for you, and you got to go back to the beginning. So I got to pretend here. Let's pretend like someone did some distributing. Okay. I have to think, all right, what do these two terms have in common? Well, an x, right? Yeah. And then, okay, if I were to multiply x times something, how would I get rx? X times what is rx? Well, I guess r. And then x times what is xs? I guess s, because that's what it's missing. And I think that works, right? Because if you distribute, maybe try it again. X times r, yep, that's rx. X times s, yep, that's xs. So I factored correctly. And this is a good thing that we have right now because instead of my variable occurring in two different terms where I used to see two x's, I've kind of narrowed it down and extracted it from both terms, and I only see it one time. So now if I think about it, I want to solve for x. Here he is. I can get him by himself pretty easily because now he's just being multiplied by something. I can get rid of this whole thing right now by dividing by it. R plus S, R plus S. That'll knock it all out at once. Because again, yeah, to get rid of something, you just say, well, what's the operation between what I have and what was given? Oh, the opposite of multiplying is dividing, and I'll do that. Because these will cancel. R plus S over R plus S, that's 1. So this is like x times 1, which is just x. And there it is. That's a weird looking answer, but what are you going to do? Oh, and that's another thing I wanted to mention. You got to be really careful on the homework. It's very case sensitive. So keep that in mind for these problems especially. Homework is very case sensitive. So it's confusing because you remember we had a capital S in the beginning and we had a lowercase s as well. So if you put maybe both lowercase or both uppercase, it's going to get mad and say it's wrong. So be careful. The top should be a capital and the bottom should be a lowercase, or whatever they give you. So they're very particular. Or like in the last example, example 6 here, you had a capital A. So if you wrote your answer with the lowercase a, they would get mad and say it's wrong and not tell you why. And then P and S, they're both lowercase, so they should stay lowercase. If you put either of them as uppercase, it's going to get mad and tell you you're wrong. And again, I wish they said why. I don't know why they can't program that in, like, hey, you got it wrong, and it's because your case, it's uppercase when it should be lowercase. Anyway, poopy heads. Okay, last one. Are you kind of sad? Me too. Don't worry, we'll move on to bigger and better things. So this one looks really complicated, right? I think whenever pi is involved, I get kind of scared for some reason because it's like this weird symbol that I don't quite understand. It's a decimal that goes on forever. What the heck kind of witchcraft is that? But, and of course they want us to solve for it. That's kind of scary. But we have, all right, a is 2 pi h plus 2 pi r squared. If you're curious, this seems like a really complicated formula, but this one I do recognize. It's if you have a cylinder. I don't know if you know what a cylinder is. It's pretty much like a soda can, that shape, that kind of thing, or a soup can. So this is the surface area of a cylinder. So if you think about like a soda can, it's pretty much how much aluminum are you going to have to use? Because there's aluminum all the way around, like this part here. But there's also aluminum on the top. How much is that? How much is on the bottom? That kind of thing. So this part actually takes care of the outer part, the amount of aluminum that would be on the outer part. The 2 pi r squared is how much aluminum is taken up by the top and the bottom. Anyway, geometry is kind of interesting, I think, but again, math nerd over here, so don't take my word for it. All right, but they want us to solve for pi. Okay. I think we're in a similar boat as we were in the last example, right? Because we see our variable twice. I see it here and here. And even though those two terms, the 2 pi h and the 2 pi r squared, they look sort of similar because they both have a 2 pi. Because one has an h and one has an r squared, they're not like terms. So I'm not able to combine them. What I'll have to do is like we did in the last one, I'll have to factor my variable out. And I know what I'm thinking too is, part of me wants to factor also a 2 out because I see, hey, both these terms have a 2, right? So can I take a 2 out? But keep in mind, we're not really factoring, to make it look pretty. We're just factoring to try to get pi by itself. All I really need to factor out is the pi. The 2 you could, but you're kind of overcomplicating it. So let's see, I'd say pi, if I take pi away from this first term, the 2 and the h are left. If I take pi away from the second term, the 2 and the r squared is left. And if you remember that part, just factoring, then these problems are pretty easy because now you say, all right, how do I get pi by itself? Well, it's pi times this stuff, so I can get rid of it by dividing by that whole crazy parentheses there. 2h plus 2r squared. Bada bing, bada boom. And of course, they cancel on the right side because something divided by itself is going to give 1. So it's like pi times 1. And then on the left side, again, you know that it's going to look terrible. You're going to want a pretty answer, but that never happens on these problems. And that's pi. So as long as you get your variable by itself, then you must have done everything right. You're kicking booty, taking names. having a good time while you're at it, you know, all that stuff. This is another thing. I meant to mention this. I wrote it in that box above that kind of describes how to do these problems. But I wanted to say, you want to make sure your answer does not contain your variable. I'll kind of explain what that means. Let's see. Make sure your answer does not contain your variable. Because that would mean you didn't really solve for your variable. So when would that happen? Let's see. Imagine, you know, you started with this example in the very beginning, a equals 2 pi h plus 2 pi r squared. And let's say this, I see this a lot. People think that, okay, this is the easy way. Let's say you say, well, here's pi. I can get it by itself by moving this guy over, right? First, I'm going to move this guy over. Okay. Right, okay, he moves over. Then let's see what happens. A minus 2 pi r squared. Now if that's gone, all that's left on this side is 2 pi h. And then I can get pi by itself by dividing by 2 and dividing by h. So that'll work. Now pi's by itself. Pi is this thing. But no, pi can't be on both sides. You know, it's like you said, oh, don't worry, I captured, I don't know, some wild animal. I got him, look, it's here. Like, no, look, he's out in the wild still. What the heck? You know, you shouldn't have if you say I caught this thing and I found out what it is, you shouldn't see it out there in the wild. This is not right. You shouldn't see the variable you're solving for on one side and the other. That means you didn't really solve for it. You kind of did I don't want to say half-assed job, but, you know, something like that. But it's hard to know that you're not doing it right, you know, so keep that in mind. So you don't want to do it this way. I kind of want to erase that just to show that was not a good idea. Yeah, so that's the thing. If you see your variable in more than one term, it's not enough to just isolate one or the other. You have to do both. So, hopefully that was fun. Hope it made sense. I'll see you guys in the next video, and have a good time.